Well, dear students, hitherto we have studied refraction of light through a glass slab, and that experiment we have conducted to verify the laws of refraction of light. Today, we just check up another definition of refractive index. What is refractive index? Which we have understood. According to Snell's law, that is second law of refraction, which states that the ratio of the sine of the angle of incidence to the sine of the angle of refraction is a constant for a given pair of media, and this constant is called refractive index of the second medium. So mathematically speaking, mu equals sin I by sin r. That is the first definition of refractive index. And refractive index can also be defined in terms of velocity of light or speed of light. Velocity and speed mean the same here. Now, what is a refractive index in terms of velocity of light? It is defined as the ratio between velocity of light in air or vacuum and velocity of light in the medium. Again, I repeat, refractive index is defined as the ratio of the velocity of light in air or vacuum to the velocity of light in the medium. That is the thing there. Based on this one, I can define a refractive index like this. Suppose I say refractive index of glass is 1.5. What does it mean? It means that velocity of light in air or vacuum is 1.5 times more than its velocity in which medium? The glass medium. I repeat, suppose I say refractive index of glass is 1.5. What do you mean by this statement at the public examination? Your answer should be like this. Velocity of light in air or vacuum is 1.5 times more than its velocity in which one? The glass medium. I hope you understood. Suppose I say velocity of light in diamond is which one? 2.5 times in air or vacuum, let us say. Or we can say that. What do you mean by saying, what shall I say, refractive index of diamond is 2.5. Now we can define like this. Velocity of light in air or vacuum is 2.5 times more than its velocity in diamond. I repeat once again, velocity of light in diamond is 2.5 times actually less than the velocity of light in air vacuum. The other way I am just saying. Or once again, if you want to say or if you want to define refractive index of diamond is 2.5 means velocity of light in air vacuum is 2.5 times more than its velocity in air vacuum. I hope you understood. That is, now I am just showing this one. Velocity mu equals, mu means refractive index, is equal to velocity of light in air vacuum divided by velocity of light in the medium. Now, we will just take up how does refraction of light take place in a prism, because I have just taught you the refraction of light in a glass slab. Now I am just changing to glass prism. How does it take place? When you just take into account which one refraction of light through a prism, here you can't just think of white light. If you just pass white light through a prism, you know what happens? It disperses into 7 different colors. And therefore, when you study the path of the ray through a prism, you have to consider a ray of monochromatic light. Monochromatic light means, mono means single, chro means color, single color light, that is called monochromatic light. What will happen? Now, I will show the figure. In the figure, ABC represents the cross section of a prism. It shows the cross section of a prism. What does ABC represent? ABC represents the cross section of a prism. What is A? Angle of the prism. What is BC? Base of the prism. How do you define angle of the prism? Angle of the prism is defined as the angle between the two polished surfaces of the prism. Here in the figure, AB and AC are the two polished surfaces. The angle between them is called angle of the prism. And BC is actually the ground face, that is base of the prism. BC is the base of the prism. Now, what does PQ represent? PQ represents a ray of monochromatic light. I have already told you. Let us consider a ray of monochromatic light incidenting on one of the polished surfaces of the prism. What will happen? The ray of light travels from glass, not from air to glass. When it travels from air to glass, that means it is traveling from rarer medium to denser medium. You know what happens? When a ray of light travels from rarer to denser medium, it bends towards normal. You please see its path is along QR. QR is called the refracted ray. PQ is called the incident ray. Once again, the ray does not keep quiet inside the prism. It must just get out. While getting out, it is traveling from glass to air. When it travels from glass to air, it is traveling from denser to rarer medium. When it travels from denser to rarer medium, what happens there? What kind of bending effect? It bends away from the normal. Therefore, the ray of light is now traveling along RS while getting out of the prism. RS is called the emergent ray. RS is called the emergent ray. Once again, PQ is called the incident ray. QR is called the refracted ray. RS is called the emergent ray. Please understand another point. Suppose you don't place a prism in the path of that light. What will happen? PQ would have continued to travel along its own path, which is represented by which one? Dotted lines. Because you have placed a prism in the path of light, it is now traveling along RS. It is emerging out of the prism along RS. That means its path has been, original path has been deviated through some angle. And that particular angle is called angle of deviation. How to find out that angle of deviation? You produce the incident ray forwards and the emergent ray backwards. The angle formed between them is called angle of deviation. In the figure, it is called now here OTS. See that? OTS is called angle of deviation. That is the angle through which the original path has been deviated. So that is angle of deviation. Now comes the question. What are the factors on which this angle of deviation depends? What are the factors on which angle of deviation depends? Angle of deviation depends upon four factors. What are the four factors, sir? The first factor is angle of the prism. If the angle of the prism changes, 60, 65 ಆಯಿತು, angle of incidence changes. So, you must understand, as the angle of the prism changes, angle of deviation also changes. That is the first factor. Number two, angle of incidence. If you change the angle of incidence, angle of deviation also changes. And the third one, material of the prism. It means mu of the prism, that is refractive index of the prism. As the density changes, what happens there? Bending effect also changes. When bending effect changes, certainly angle of deviation changes, and therefore it depends upon the material of the prism. Material of the prism is as good as my saying mu of the prism. The last point is actually the color of the light. All the colors will not bend to the same extent, as you know. Different colors bend to different extent, as a result of which dispersion of light takes place. That is the reason how dispersion of light takes place, which I am going to take up a little later. Now here, dispersion of light takes place because the colors will bend to different extent, and therefore the fourth factor is color of the light. Therefore, what are the four factors? Please here, you please see that once again. I am revising it. The first factor is angle of the prism. The first one is called angle of the prism. Second one is which one? Angle of incidence. The third factor is the material of the prism. The last one is which one? Color of the light. It is also wavelength of the light. As wavelength changes, the color also changes. And they are the four factors on which angle of deviation depends. Then we shall just take up in continuation with this one. What is dispersion of light? It's a very simple fact which you have studied in the previous classes. So what is dispersion of light? Splitting up of light. The process of splitting up of white light into 7 different colors when you pass through a prism is called what you call dispersion of light. Dispersion of light means the process of splitting up of white light into 7 different colors when passed through a prism. That is referred to as what you call dispersion of light. Okay, then comes the question. Why does dispersion of light take place? Dispersion of light takes place, as I have already told you, different colors bend to different extent. That is, you must know that one, it depends upon mu or it depends upon the wavelength of the light. As the wavelength, white light is made up of 7 different colors, different wavelengths are there, different wavelengths bend to different extent, and therefore dispersion of light takes place. So dispersion of light takes place because different colors will bend to different extent, and white light is made up of 7 different colors. And therefore, now that is what is dispersion of light over. Why does dispersion of light take place over? Now, I'll just take the experiment here. What is a spectrum? The next question for us to answer is, what is a spectrum? Okay, sir. Pass white light, very important, pass white light through a prism. What will happen? It splits up into 7 different colors. And if you place a screen in the path of the emergent beam of light, you get 7 different colors. I call it a band of 7 colors. Band is a collective noun I am using. We get a band of 7 colors on the screen. Again I repeat, when you pass a ray of white light through a prism, it splits up into 7 different colors. And if you place the screen in the path of the emergent beam, you find 7 different colors on the screen. This band of 7 colors is called a spectrum. I hope you understood. Again I repeat for the last time. Now pass white light through a prism. It splits up into 7 different colors. If you place a screen in the path of the emergent beam, we find 7 different colors on the screen. This band of 7 colors is referred to as what you call spectrum. If you observe the spectrum clearly, you will be able to see that violet color bends most. V represents violet. Violet color bends most. Red color bends which one? Least. What are the different colors? The colors are remembered by the word Vibgayar. V-I-B-G-Y-O-R. I think you know different colors. Violet, indigo, blue, green, yellow, orange and red. They are the 7 different colors that are formed on the screen in an order. Violet bending most, red bending least. I hope you just understand this particular point. And then, alright sir, 7 different colors. But this spectrum is called impure spectrum. Sir, why is it called impure spectrum? Because we are not able to see the colors clearly and distinctly. Because there is overlapping of colors. Because there is overlapping of colors, we are not able to see the colors clearly and distinctly. And therefore, this spectrum is called what we call impure spectrum. Then comes the question. Sir, how to get pure spectrum? It is another point. Before discussing how to get pure spectrum, why is it that spectrum is impure? That is, overlapping of colors has taken place. Why is it that it has taken place? Please understand. When you pass a ray of light, white light, It is actually what happens there. It is a point source of light and it is a divergent beam of light. You see that? You please see that? It is a divergent beam of light. It is a divergent beam of light. When you take a divergent beam of light and you just incident on the prism there, all the rays present in that light will not incident at the same angle of incidence. Angle of incidence changes, correct? Because it is a divergent beam of light and therefore different rays incident on AB at different angles and each ray will produce a spectrum and they bend to different extent there, you please see that, and therefore there is overlapping of colors. Answer is the here angle of incidence changes. All the incident rays will not incident at the same angle. That is the answer. That is how a pure impure spectrum is there. Overlapping of colors is there. Suppose you make all the rays incidenting on AB at the same angle, you get a pure spectrum. How to do that one? You can just do it using a convergent lens, that is a convex lens. Suppose you take a ray of, suppose you take a biconvex lens, you can see in the figure. The rays coming out of the lens will be rendered into a parallel beam of light. Parallel beam of light. Suppose you pass this one through a prism there. Angle of incidence remains the same because they are parallel to each other. Angle of incidence remains the same. Therefore, the overlapping of colors will not be there and that kind of spectrum is called pure spectrum. I hope you have understood how exactly pure spectrum is different from impure spectrum. In the case of impure spectrum, you find overlapping of colors. This is on account of the rays of light will be incidenting at different angles, but when all the rays will make incident at the same angle on the prism there, using a biconvex lens, you will just get a pure spectrum where you don't find the overlapping of colors. Okay, I would like to stop my lecture at this point. Thank you. Bye.